Hello everyone, this is the video where I explain the proposed solution of a project which is implemented. And before diving into the solution that we have designed, let's revisit the problem statement once. Our platform name is Parametrix, which is an AI powered parametric insurance for gig workers. So basically, gig workers work on several platforms like Zomato or Swiggy or Dunzo, for example. And generally they work on like a daily basis and they get money for what they work, and in case there is an external environmental disaster happening at the place where the gig worker is working, and there will be no orders that are going to be issued for the worker, and he is going to lose his income for that day or for that period of time where the environmental disaster is happening. So to compensate him, he is provided an insurance plan where he is going to pay a premium price. Like, if let's say a weekly premium is costing 20 rupees, the coverage limit is 800. In the case of a hazardous situation, this 800 rupees will be sent as a claim by verifying his location and also the weather, and then the amount will be credited to his account. So let me go to the architecture. And this is the architecture of our project, where the worker will have a front end dashboard to manage his payments, and the back end will have a Kafka event system, which is we are working on a microsystem architecture where we have modules like trigger engine, fraud detection, claim service, and payout service. Each dedicated microservice has its own part playing in order to get the user the best they could. So, and the Kafka event system is the system which integrates every microservice and takes and streamlines the data between the microservice. Like, let's say there is a hazard in Hyderabad and a worker is working there. So suddenly the weather turned very dark and heavy rain started pouring out, and the trigger engine is going to trigger a alert to the fraud detection microservice, and the fraud detection microservice will verify the user if he is paying the premium, right, and also is he at the current location where the weather is not good, and send it to the claim service. Claim service is an automated claim processing service which generates a claim that he needs to be received. The user is going to need the money, and the payout service credits the amount to the user using the payment gateway. So the additional components we have used in this model are the risk engine and also the Redis cache. The risk engine is nothing but which uses Open Weather API and also Acquis database to measure the air index quality and get all the required parameters to say that the weather is okay here. Like, it actively monitors the weather over a particular area and triggers the trigger engine if sends alerts to the trigger engine if it doubts that if there is an actual environmental hazard going on. And coming to the technology stack, we have used Next.js for our front end, and we have went with a microservice architecture in Spring Boot. And for event streaming, as it is an event driven architecture, we have used Apache Kafka. And while we are working with users at scale, it is and must for optimizing the application performance. We have used Redis to reduce the latency between the user application front end and also our back end, because every database call is cost something. Instead, we will stop at our RAM and check if that request already exists and return the data to the user. So for the database part, we are going with MongoDB, and remaining are build tools, dependency management, API documentation, and we have containerized the complete application using Docker. So coming to the microservice architecture, there will be a worker dashboard and also an admin dashboard for the front end, and an API gateway which routes all the requests from the front end to each microservice based on what user is navigating to. And so these are the API endpoints of our project, and these are the Kafka topics we have created, like, is a worker registered, when a worker registers into the application, this topic is going to get active. So such that for each operation, let's say there is a trigger happened and the claim needs to be initiated, this topic is going to be active. Like that, each topic is active at some times and collect messages from each other microservices. In this way, Kafka system distributes the messages between the microservices, streamlining the application. So this is our project structure, and these are all the technical details we have done in the project. So moving on to our application part, this is the landing page of our application. So we are providing users the ability to pay insurance for, in case a hazardous event happens, they should be able to survive using the income that they have paid for. Like they will pay a weekly premium and get a coverage limit, and the payout time would be less than 1 hour. In less than 1 hour, the fraud detection is going to evaluate the user, and the claim generation happens, and finally the payout, like the amount will be credited to the user's account. Yeah, let me demonstrate the application. Click on get protected now and enter the user details. I am entering currently the test user details. So the mobile number 6789. Yeah, city, let's say I pick Delhi, and as it is supported for multiple platforms, we have given the user the option to pick a platform. So let's say I pick Swiggy and create the account. Okay, the password must be. So this is going to be the user dashboard, and this is where he can monitor everything, like what is the coverage he is going to get, what is the total paid amount, what is the pending amount, and what is the risk score at his location. Initially the user won't have any plan of his own, so he is going into my policy section and he will purchase a weekly policy. So for demo purposes, we didn't integrate any payment gateway currently. In future, we are going to implement external payment gateways like Razorpay or Stripe or PayPal. And this is the claim section. So this is the payout section of the user, where he can monitor all the payouts he got till now. And let me navigate to the admin dashboard. So admin dashboard is like the super user of a Linux system. Like in the overview section, I can manage all my microservices and see how they are working. Like if I look at here, all the microservices are working perfectly, and there is always a health check happening. Like API/health is an endpoint where it will check if the particular microservice is working or not. And these are all the claims processed, and the active policies running, and the payout exposure, how many payouts are done and how many events are going to be streamed. Let us explore the admin dashboard one by one. And this is the simulation section. So generally the user registers into the application and buys the policy, but for demo purposes we need to simulate a weather hazard, so that I need to show you how the claims are going to be generated, right? I can't just wait for the weather to happen, weather to go wrong, and then the claim is going to generate it. Instead, I am going to generate a simulated environment hazard, where let's say I selected the city as Delhi, right? And there is extreme heat happening in Delhi, and I create a value for the simulated value, and I set the severity to critical. Let's say this goes on for 2 hours, the extreme heat, and I am going to trigger the simulation. The simulation happens right away and stays for 2 hours. Going to the claims, if you check, there are 3 claims happening right now. The first claim is validating if the air pollution is real or not, and the second and third claims were already paid out to the users. And we are going to see the active policies that are over here, and there are 2 users in Delhi and 1 user in Hyderabad, and they are paying the premium as well, and they got their claims into their accounts. Okay, and these are the workers that are registered into the system, and we got their name, city, and the gig type they are working, and their contact details and the status. So coming to the events, all the environmental disruptions, how they are happening, when they are happening, we are going to look at here. And the system logs, like this admin simulator is nothing but I have synthetically created a situation where the environment went wrong. Instead, when it happens naturally, instead of admin simulator, this is going to be labeled as risk engine. Yeah, this is all about the admin dashboard, and it is all managed well, and we can monitor everything from over here. And as for we are using, as it is an event driven architecture, we are going with we are going with Apache Kafka. So we can't view what are the events happening without a proper dashboard. So we have this is an open source dashboard for viewing the event brokers, topics, and consumers in the event driven architecture of Kafka engine. So coming to the topics, like if there are claims which are approved, right? If I go into the claim approved status, there are going to be 3 messages because I have approved three claims and the users have received their money. And in this way, there are several topics for claim initiations, claim validations, environmental disruptions, payout completions. Let's check the payout completion. So there are 3 payouts which are completed. Okay, let's go into the overview. And in such way, there are several topics. Coming to the consumers, there are nothing but the microservices which are registered into my system. Like this Apache Kafka has stayed the central pillar for all these 4 services. And yeah, this is all about the Apache Kafka system. So when I log out and log into other user who had already received a claim. So if we check that he has took a policy already and he has already got his claim, right? If he got his claim and he tries to buy another policy, it will be not possible in the same week. He has to wait until next week comes on. And going to the claim section, it shows all the claims that he had received, and the payment section will reflect all the total money received, which is currently 0 because the payout we haven't actually integrated any payment service, right? That's why it is showing as 0. In future we are going to integrate services such as Stripe or PayPal to ensure that the users get the amount safely and securely. And this is the dashboard so at the location where we are monitoring weather conditions in Hyderabad. So the risk score, the risk score is currently 34%. Based on the score, the amount he gets also gets affected dynamically. This is all for the project. Thank you.